All right, this is on the factor theorem. So when we look at the factor theorem, we have our function and it's factored out with our divisor, our quotient, and then our remainder. With the factor theorem, if when you evaluate the function for some number and you get 0, then that factors out completely, giving you a divisor. So you're going to use synthetic division most of the time. You can also use long division. Okay, so here's what it looks like. Here is your equation. It's a cubic function and you want to use your factor theorem. They give you that 3 is a 0 of that function. So we're going to have our synthetic division box with our placeholders. They put our coefficients underneath. And then they say that 3 is a 0 of the function. So we're going to factor that 0 out. So in factored form, this is what it looks like in factored form. It's x minus 3 in a parentheses. So we're ready to do synthetic division. So we're going to bring down the 2. We're going to multiply 2 times 3, which is 6. We're going to add the column. We're going to multiply 3 times 3, which is 9. We're going to add the column. We're going to multiply negative 2 times 3, which is negative 6. And we're going to add the column. This is what we want. We want that remainder to be 0. That's telling us that that x equals 3 is a 0 of the function and can be factored out. So we are factoring out that x minus 3 from the function. And now we're going to be left with the new polynomial. This is where the new polynomial comes from, is underneath the synthetic division. So you're going to drop a degree. This is going to be your x squared term. That's going to be your x term. That's going to be your constant. So now we can write it inside of there. Now we want to continue solving this function for x. So we have this quadratic factor that we want to find those last 2 zeros. So we're going to set that purple circle, the quadratic, equal to 0, and we're going to solve for x. So we're going to factor it. So we'd either use our AC method or our slide divide bottoms up. So I'm going to slide it. 2 times negative 2 is negative 4. I'm going to factor it. I'm going to divide by that slide. I'm going to simplify the fractions. And now we go bottoms up. So this bottoms up. All right. So in completely factored form, that function has the x minus 3 that we took out using synthetic division, and then we factored that quadratic to be x plus 2 and 2x minus 1. So now to find all the zeros of the function, which will be your x-intercepts, you set those factors equal to 0. So remember that x minus 3 equals 0? Well, there's your first 0, which is your x-intercept at 3, 0. Then you have x plus 2 equals 0. Solve it for x. There's your next x-intercept. Your last factor, add 1 and divide by 2. So your last factor is solved out. Here is the graph of this function. It's a cubic function. It rises, it turns, it falls, it rises. So with the graphing calculator, that is your cubic function, and here are your 3 x-intercepts. Which those 3 x-intercepts are the zeros of the function. Use synthetic division to divide this function by x plus 1. So we're going to set up our synthetic division box. X cubed, x squared, x constant. Put our coefficients in, 1, -4, 1, and 6. Now what we're dividing by is the factor x plus 1 equaling 0. So we're going to solve that for x. And that's what's going to go out in front. So we're looking to see, is x equal -1 a 0 of the function, which will then be an x-intercept? So in factored form, it's x plus 1. All right, let's go ahead and do our synthetic division. Bring down the 1, multiply 1 times -1, which is -1. Add the column. -5 times -1 is 5. Add the column. 6 times -1 is -6. Add the column. Just like the last example, our remainder equals 0. So that tells me that x plus 1 is a factor of that cubic function. So we're going to write the function in factored form. We're taking out that x plus 1 factor, and now your leftovers are going to go in the second parentheses. So now we drop a degree. Since we had a cubic, we're now at a quadratic. Those are your terms. So we have x squared minus 5x plus 6. Now it says use the result to find all of the zeros of the function. So there's 2 more zeros left. So this is still x plus 1, and now we factor that. What are the factors of 6 that add to -5? That should be a -6 there. There is our function in factored form. So our zeros are at -1, +6, and -1. These are repeated. So those two x equals -1s are a multiplicity of 2, which we know from earlier in our unit. When we have an even multiplicity, at that x-intercept, it does not cross the x-axis, it bounces off.